Okay, so it's our final presentation. My name is PINGYUAN and my teammates is CHEN. We are Group 9. Initially, our topic was social media and investment. So basically, we want to see if we could use customers' review data from stock tweets to predict the stock's increase or decrease. And then we want to build a model on Yahoo Finance data to see to predict the stock's increase or decrease. And we want to compare those two results to see which one is better. But unfortunately, because the data on the stock tweets is very messy, and I will explain the details later. And also, both of us do not have too much background in computer science and big data analytics, so we only have the second part done, which is using the Yahoo Finance data to predict the stock's increase or decrease. So here is our topic: Yahoo Finance stock data analytics. Well, business value, people talk about big data analytics everywhere and almost like every day. So we want to see if that is possible. We could build a model to predict stocks increase or decrease to help investors make better investment. That brings our motivation. Okay, let's go to our models. So the data is meaning on Yahoo Finance data, and initially we download all the data from Yahoo Finance, and the data size is around 3 GB for all the stock and all the time. And the algorithm is classification method, basically 4 different classification method. And you can see here, naive-Bayes logistic regression, random forest, and support vector machine. And we use R, Python, and Spark to do our analysis. This is a sample data from Yahoo Finance. This is a sample for the Apple. So you see there here are open, high, low, close, and volume, and adjusted value. Okay, at first we use the first 10 stocks from the first 10 index from the S&P 500 to run a test data, since we don't want run like 3 times for 12 models on Spark. So actually we pick a small test data to see which model may perform better, and we would select this one as our final model to run the analysis on the overall data. The model 1 is basically we use close minus open, and if that is greater than 0, we would mark this stock as increase, and if that is smaller than 0, we would mark this as a decrease. So make it as 0 and 1 as increase. So the first model is we use first 3 days increase and decrease to predict 4th days increase and decrease. So for example, for the first observation, which is this one's increase or decrease as the response value, and those 3's increase and decrease as independent variables. And the second model is we use this one, the 4th day's increase or decrease as the response value, and those 3's close minus open, basically the difference between close and open, as 3x. So we want to use those 3 to predict this one. Would this one increase or decrease? And the last model is we use previous days open, high, and low value to predict 4th days increase or decrease. So basically, the first observation is XAR, this one. XR, this one, and this one, and the Y is the increase or decrease for this date. So those are our 3 models, and those are the test data and the result. So you can see lots of the predictions for the model 1 from this part gives like all the predictions are increase. Well, this one is a number of data in the test set. Basically we use 80% as training data and 20% as test data. You see lots of the predictions predict that the stock would increase. So you see this one is predict all the stock would increase, and all increase, and slightly lower increase, like smaller increase. This one is model 2 and model 3. You can see the result here. So I'm not going to spend too much time here. And actually, finally, we decided to use model 1 with naive-Bayes and model 2 with support vector machine as our 2 models. So we would run those models on Spark and see which one performs better. Okay, so here it brings our overall approach to the final model. At first, we download 10 years S&P 500 data from Yahoo Finance, and then we clean the data to the format that Spark required in Python. And then we convert the data to libsvm format in Python, because because we want to use Scala to run the support vector machine model, so we have to make the model as this format. And then we use the Spark and Spark R in R to run the naive base. Okay, and here is our conclusion. Basically, the model, you see, the model 1 with support vector machine, the final result is here. It predicts like 50.4%, so basically it's like a random guess, which is pretty bad. And this one is a model from the naive base, so basically we run this model on our Spark, and actually it requires the max input of data size to be like 1 megabyte, I think. So after I clean all the data for the S&P 500, the size of the data reduced to like 40 megabytes. So actually I run it many times, and the final result for this model is 53%. So actually the naive base with model 1 performs better. And actually I think the just on the machine learning algorithm on the Yahoo Finance data, I think the 53% is acceptable, because the variables are defined as 1 and 0, which means increase and decrease. So actually the value can only be 1 and 0, thus the predicted result would like very close to 50%. If that is higher than 50%, I would say that performs okay, but it's not like super good. So it's about our future work, and actually, since we two are not very familiar with big data analytics, and actually none of us are computer science background, so actually we two are super new to this field, and we tried at first we want to use the social media data, but actually there's lots of problems that we wasted lots of time, but actually we did not have a final product, final result done. So here I would discuss some of the efforts we tried. At first, we get the data from a AI researcher. So, and actually I referenced him in our final report. So we get the stock twist data from him, but actually the data is stored in MongoDB. So we spend lots of time to learn how to use MongoDB, and actually we get some data. We get the data out from MongoDB, and we tried to use some sentimental analysis on the stock twist data, but actually the result is not good, because we want to see if the result is positive, we may define that as increase, and if the result is negative, we may define the we would define the result as decrease. So basically predict the stock would decrease. However, lots of comments do not have like a strong opinion. Well, lots of the data give like 0.6 or 0.7 positive or negative. Well, so it brings the first question: how positive is positive? That's the first issue we have to solve. And secondly, in online platform, the data is not independent, so we want the observations to be independent. But if the first person posts the reviews on a specific stock on a specific day, that could be assumed as a independent, because he did not say any previous post. But actually, if people post behind him, it's not independent. Anyway, we cannot assume it's independent, because the data would because this guy may look at previous posts and thus his opinion may be influenced. So actually we could not assume the independence of the observations. And then the reviews for each day and for each stock varies a lot. So for some stocks they may don't have too many reviews. So actually the size of the data is too small, so we cannot cover lots of data. And then the last question is people write comments on specific days, specific stocks, and it's very difficult to have a standard to give a weight to the predictions. So for example, if this guy predicts 10 times correct but 5 times wrong, and then another guy predicted 100 times right prediction but 1000 times wrong prediction, so how can we deal with these weights? And those are kind of for the work we should do. So that's why we did not run the sentimental analysis on the stock twist data. And okay, so basically that's all about our project. And thanks Dr. Ling, and thanks Eric Johnson, and thanks all TAs. Appreciate this semester. And actually I think this class brings me to a new field, and I do feel I love this field. And actually I think this project is not I'm not very satisfied with this, but actually I think I tried I put lots of time in this and I really tried. So anyway, I will continue to learning more about data science and big data analytics. Thank you.